Yes, sir. Now it is live streaming is on and recording is progress. Uh, shall we start, sir?
Up to you.
Okay, sir. Okay, we'll start, sir. Uh, Good evening, everyone. Today we have Dr. N. Krishnamurthy with us. He's a consultant, safety, structures, and computer application. I was just glancing his biodata. He's having lot of achievements, vast knowledge. Actually, we have already had one interaction with him in the previous phase. We had a wonderful session, and it was highly informative, and he is also highly knowledgeable. Um, it is my immense pleasure to introduce him for this today's webinar uh, in forensics in civil engineering. Now he is having more than 35 decades of 3 decades of experience in this field. He got his MS from University of Colorado, and he is graduated from Mysore from India. He holds the citizenship of India. That is what sir is very much interested to come back to India. That's what he's telling in the last meeting. And he always used to interact with us, and he's also used to tell he's having one baby in Mysore. That is his institute, whatever he's leading it. And he's having lot of achievements in his life, and he is having, and one interesting what I seen is biodata is his hobbies, life counseling. That is what I felt very interesting in his biodata. He is also he's having the habits in poetry, reading, and journalism, photography. Even photography is not easy to get the beautiful pictures, and he is also interested in that. His innovation is Sapphire Diamond, that is computer graphic based techniques for risk assessment, that is patented one, and barcode, that is a scaffold and false work modular system, again it is a patented one, and safe walker atomic seat support for walking persons collapse. And next one is Krishna Deva, a Sanskrit English translation scheme, a copyright in India. These are all his innovations and publications. He has 5 technical books, 4 co-authored books, 100 technical papers, 10 journal books, many journal articles. That means many of the things, and he is also a professional member, and even he is a fellow member of ASCE, and he is American Society for Safety and Professionals. He is a member. Most of the achievements, sir, in one word, he has achieved a lot in his life, and his lecture will enhance our knowledge in forensics in civil engineering today. And I'm happy to introduce today's speaker to this gather, whatever we have. And most of the people, they used to join now, they will join after this. Sir, please take over the session, sir.
Okay. Thank you, Sanat Kumar and Shrikanta, for getting this started. There are 47 participants last time I spoke. So either it is because it is Saturday or because I'm not a good speaker. Whatever, I'm joking, don't worry. Because even if there are only a handful of you, I'm happy to share.
No, they will definitely they will join, sir.
I know. Yeah. But I, of course, having spent a lot of time in foreign countries, I value my time, I value my audience's time. And I think in India, we have quite a few problems in traveling, communication, and so on. So I'm trying to adjust to the realities of India. Is my voice clear to everybody?
Yes, sir.
Okay. And actually, forensic engineering, I give an entire university course on it, 30 to 40 hours. Oh. It's a huge subject. And in 1.5 hours or so, I can only show you a few things that can be done with it. My privilege and happiness is that I have done something on my own. Normally, a professor can talk about anything if he pays attention to it, if he studies, and then he speaks reasonably well. And these days with PowerPoint and so on, he can impress. But then there is a difference between listening to somebody who has done some things in that area. So that is why in structural engineering, in computer applications, and in risk management and related subjects, I'm very lucky to have done some things at various levels. And then forensic engineering is, in a way, you can call it accident investigation. So that is something rare. People probably are experienced with accidents. Then they call the ambulance, they call the police, and somebody investigates, and they try to find what went wrong and so on. So it is a specialized area. But then right from the United States, I was lucky to be involved in not accidents, but the investigation of accidents. So it's a very interesting science. It is actually detective work. If you like detective stories, if you think you want to be a detective, then you must specialize some of your skills. It doesn't come easy. It may be you have an academic background, you may know the theory, but real life is very different from theory. You see it in the movies, you see it in the serials, but they're all exaggerated, meaning it's a 1 hour program or a half an hour program. Everything gets wrapped up in exactly 18 minutes or 20 minutes. You start somewhere and you end somewhere, but life is not like that. Anyway, I'll try to share with you what I know, what I have taught, and also my experiences. I'll stop at about 10 minutes before your 6 o'clock and allow time for questions. I think it should be okay. Okay, so let me now go to my slides, and I have arranged them in such a way that there is a smooth flow. So I'm sure you can see my slides. Of course, I'm flicking backwards to get to the beginning. Can you see the slides okay?
Yes, sir.
Okay. So I'm
Yes, sir.
assuming my voice is okay, audio is okay, video is okay.
Yes, sir.
And this is my opening slide. And like last time, I'm showing that I myself took some time to understand what the abbreviation BMV NFTSA meant, and now I know. I want you to also, all the audience also knows about it, I guess. And then today's topic is forensic engineering, and I'm speaking for BMVNTFSA. And you see my name, and at the bottom, you see my website. If you have time, you may visit it. There are a number of free publications which you can browse and use. And I'm also, the brochure this time omitted that, but apart from being a consultant in Singapore, I am the founder director of the Center for Workplace Safety and Health in NIE Mysuru. With that, I also had the good fortune to have met Sir M. Visvesvaraya. He's a very rare person, very special person, and he's a role model for all engineers. And I'm happy I took this picture. I was just starting my career as a teacher. He visited my institute. That's the minister next to him. And in my time, all the teachers and others were wearing turbans and panchakachas. So you can imagine, I'm talking about 1950s. So I feel lucky that I'm talking to a group named after this legend. Now, just one slide about my center. This was inaugurated in 2019 by my former student, N.R. Narayan Murthy, who is famous for Infosys. And because I established it with my funds, they call it after my name, but that's not important. And then our motto is very simple. We are here to keep you safe, or if you're already feeling safe, we make you safer, not only at your workplace, but elsewhere also. And without going into too many details, we plan to raise the awareness of Indians in workplace safety by in-person courses, webinars, training sessions like this one on various aspects of safety and health. Okay. And of course, you can learn more by contacting us, looking at our website, or contacting us through email. Don't hesitate to do that. We will supply any information you want. Now I come to the topic for today. Luckily, I'm given a small topic. Forensic engineering is a huge topic. 1 hour, 2 hours won't do. Forensics engineering and civil engineering is about 1 week's topic. Forensics in structural engineering is a whole day, but I'll try to touch the highlights of it. Now, today I plan to cover why do accidents happen and why study them, what is forensic engineering, basics, and famous structural failures and forensic findings, and my own limited experience in this area. How do accidents happen? Of course, we may say karma, fate, but most accidents happen because unless the equipment is wrong and unless it's a natural disaster, it's usually a human being who forgot or who neglected to do something right. Don't blame others. Don't say, I was driving all right, but the other guy came and hit me. It's usually the other guy. We never make a mistake, right? So in forensic engineering, honesty is number one. Otherwise, they won't take me as a forensic engineer. I have appeared in courts on behalf of the government, on behalf of private parties, and any time they catch me in a bluff, I am out. My career is gone. Everything hangs in the balance of integrity, knowledge, and proper presentation. It's not enough to have knowledge. You must be able to present it correctly. You must be able to apply it correctly, never make a compromise. So I hope everybody wants to be a forensic engineer. In India, it's not yet popular, but abroad, it's one of the very popular and very highly paying subjects, very tough also. Okay, there are many causes of accidents, unsafe acts by human being. I won't read everything. I just want to show you, and then you can grasp it. And then if I have time, I'll go into details. Unsafe acts are done by individuals, workers, supervisors, and so on. Unsafe conditions are established by the management, by the government. So we often blame a person while behind it, the condition is wrong. Suppose we say, why didn't you attach your safety harness to an anchor? And when I investigate, there is no anchor. Or once in a while, the hook of the clamp will not go into the eye of the anchor. So many times it is unsafe condition. And then there are many contributing causes. This slide divides it into safety management performance, mental condition of worker, physical condition of worker. Okay, so it is a lot of things contributing to accidents, and the result is starting from mere annoyance, discomfort, and so on. It goes worse and worse, production delays, reduced quality, spoilage, property damage, minor injury, disabling injury, and finally fatality. Fatality means death. Okay, so these are the various consequences and causes of accidents. But why do we study them? You know, I stayed in the West for 20 years and then also have visited it frequently. I see one difference between West and East. We are ashamed of our mistakes. The West is not ashamed. They are not proud, but they want to share and correct themselves. So I think your generation, modern Indians should not be ashamed. It happens to everybody. Even people like Bill Gates and Einstein and so on have made mistakes. So it's okay, and it's okay to share them and then correct ourselves And the advantage of sharing them is so that others will not make the same mistake. So why study accidents? To find out what actually happened, what went wrong, and how it could have been prevented, what and who, if any, were responsible for it. Investigators do not find the culprits. That is the business of the police, the court, and so on. So accident investigators want to find out what went wrong and how it could have been prevented. That's all. They submit a report and use the findings to prevent the recurrence of the accident, to repeat of the accident, or if it is unavoidable, to reduce its adverse consequences. That is then leading to risk assessment and control. That's a separate topic in itself. That is, find out what is risk assessment and control, identify the dangers that can cause accidents. How do you know them? From accident study. So it's a cycle. Assess the likelihood, the probability of its happening, severity of when it happens, how bad is it, determine the level of the risk, determine and implement the appropriate controls. This is risk management. Now, with that done, risk management, therefore, is a leading indicator. It's a predictor of what can go wrong. So people must now get interested in risk management. The government of India is also planning to bring in that as part of Factories Act. Risk management is a predictor of accidents. For workplace safety and health, it's essential to anticipate and manage accidents. So you see, why study accidents? You investigate an accident, you find the causes, then you do the risk management that can help you prevent accidents. So if you want to prevent accidents, reduce accidents, you must investigate accidents. As simple as that. No use in hiding them, no use in being ashamed of them, no use in covering it up. You cover it up, it will come back and haunt you. It will hurt you. So example, suppose a worker falls from the scaffold. Accident investigation reveals there were no guardrails in a certain portion. Then provide the guardrails and next accident won't happen. You cannot reverse the time and make the accident unhappen, meaning not happen, but at least you can prevent it from happening again. So that is why we study accidents. So what is forensic engineering? The word forensic, very simple, it comes from the word forum. And the word forum means a group meeting, a group discussion. So the only difference is in this group discussion, we do not want to just gossip, just chat and so on. We want to be able to prove what we are saying is right. What we found is correct, not a guess, not an opinion. So forensic engineering means evidence, facts, logic, and future help. No opinions unless it's from an expert. Even then it will be counted as expert opinion and not evidence. So I'll give you more examples. So forensic means it must stand in a court of law. Whatever you say should not be satisfying to your wife or children or husband and so on, not to your family alone, not to everybody will praise you. Oh, how smart my boy is. But it must stand in a court of law. And it may not be exactly what you think. There are lawyers on both sides. So today forensic means appropriate for court of law or for public. Panchayat is okay. It doesn't have to be a state court or a federal court, a central government court or Supreme Court. Panchayat, any group of people who are eligible or who are qualified to judge relating to debate or argument, rhetorical, that is, people must be able to speak and express themselves. And it must relate to the use of science or technology. It cannot be philosophy. You cannot prove. In fact, there is still an argument going on whether God is there or not. It's a matter of personal opinion. So you cannot be a forensic engineer if you are philosophical. You can be philosophical, but you must not think your age or your philosophy or the Vedas you study, the Quran you study will help you. It won't, as I found out myself. So nowadays, forensic has come to legally sustainable documentation, usually applied to accidents as well as scientific tests and so on. But then there is an extension of it. We don't even say you must wait for an accident. If you can make a scenario of an accident, if you can visualize an accident, you are making a product. Don't wait for an accident. think how it can be badly used, how it can be misused, how it can be abused. And then if you can predict what can happen and then correct it, then you have become a forensic engineer because you use logic, you use science. My experience, half of this is before accidents, half of this is after accidents. Now, what is the process? Immediate task of an accident is, first you must rescue. Something is going on, people are being hurt. Don't get a lens and say, I want to find out what went wrong. The first order of priority is save the people from the fire or whatever is falling and so on and so forth. Give them first aid, make sure of medical attention and prevent further injuries. Protect them, protect others from getting injured. Then you can talk about damage control. You have saved the people, you have given first aid. See whether something is collapsing, prop it up. Whether you can put out the fire or stop the flood. Arrange for evacuation of people in danger. Control the traffic. Give the correct information. Don't let gossip spread from mouth to mouth. Protect the others. Stabilize the situation. Minimize property damage. Preserve the evidence. That, I am afraid, in third world countries does not happen. Something happens, there is immediately a crowd. Everybody will want to do something. And later you'll find the chain is gone, the watch is gone, the wallet is gone, and there is a nobody. And then you destroy the evidence. You are not helping. Let the medicos come and do it. Let the police take charge. Public, only when there is no police, no medical attention, and he knows what he is doing. Don't try to be too helpful. You know, somebody is bleeding from the nose and the mouth, somebody goes and lifts him, his spinal cord is broken. Don't do amateur medical attention. So anyway, preserve the evidence. Don't destroy it. Don't walk all over it. People can find out from tire marks, from shoe marks, who made the mistake, what caused it. Is there a slide? If too many people come and make a crowd, it doesn't happen in America, it doesn't happen in Singapore, it doesn't happen in advanced, intelligent countries. I mean, if you happen to see an accident, understand this. Don't let the crowd destroy the evidence unless you are a doctor, unless you are a medico, unless you know first aid. Conduct accident investigation. First, gather preliminary information. Visit the site. This is not always possible. My experience, I'm called after everything is over, cleaned out and so on, but I'll talk about it. Collect the facts, collect data. Do the interviews of eyewitnesses, interviews, and then collect CCTVs and so on, all the data, then analyze the data. Experimental analysis, mathematical analysis, or other methods. Then do the report writing. This is the procedure. Further considerations, report the accident first to a designated person. Unless you are the boss, don't think you know everything and keep quiet. Don't inform the family immediately because wrong information will go there. Inform your boss, your designated person, correctly observe the conditions, take pictures. If you have a camera, you know, today everybody has a camera, so record it, but don't arrange things. Prevent disturbance of evidence. Identify interview witnesses, avoid further disruption of normalcy and raising further risk. The more people gather, the more risk there is. Personal facilities, pencil, paper, this is for the investigator. All of this you must have. If you are an investigator, you need everything. You must plan for it. You cannot just go there and bring me a paper, bring me a pen and so on. Legal criteria and constraints always take precedence. Sooner or later, the case may go to court, especially if somebody's major injury or death or property damage, it will go to court. So it is the lawyers that will argue and the judge must decide. So everything that you do must be legal. If it is not legal, it's only philosophy and it may or may not stand up in court. Report the findings, recommend corrective and proactive recommendations, develop a plan for corrective action, implement the plan, evaluate the effectiveness, and make changes for continuous improvement. What is the whole purpose of this exercise? We want to reduce the accidents. So if it is just a paper published or an award or a medal or something, it's no good. What you do must end up in improving the life. Your participation in it, active participation in it, must leave this place better than you found it. Otherwise, in fact, even an engineer, definition of one is somebody who solves problems and leaves the world better. Today, we are leaving the world worse than it was. What are the basics of forensic engineering? Physical evidence. Evidence, evidence, evidence. If it is not evidence, it is just gossip. Just because a big guy says, and so I think it should be like this, I think it was he, it won't fly. It won't fly, it won't go. Before attempting to gather information, examine the site in a quick overview. Take steps to preserve the evidence and identify all the witnesses. Talk to them before they get mixed up. You know, somebody saw something and he speaks to his friends and his friends pat his back and so, it's not like that, fellow. It should have been like that. And slowly he changes his mind. And also people forget. And people imagine things to become heroes, or they won't be villains. So even if it is a mistake, he says, no, it cannot be like. So in fact, interviewing witnesses is an art. There is a whole training course for it. Now, in many jurisdictions, accident site must not be disturbed. There will be a yellow tape or a red tape and people must not come in here. Normally, in most advanced countries, next to the ambulance, next to the police, forensic engineers. Only then family will be weeping and so on. That's okay, but they're not going to help. So anyway, in many countries, in America, I know for a fact, the forensic team goes with the ambulance or the police. In fact, sometimes they get precedence unless somebody's life is in danger. The forensic engineer gets precedence over the police. Then the police will come in only to see if there is a crime to be charged. So in India, I think we have got a long way to go. Physical evidence is probably the most non-controversial information available. In fact, you study the cases. Anywhere in the world, most of the cases will be decided on physical evidence. I know, for instance, I was an expert witness, stood in the before the judge for 3 days, gave a lot of information and analysis, and the case was moving one way. On the last day, one witness gave some evidence and the case went the other way. Whom can we blame? We say, oh, the judge let off. Why did he let off? Maybe he's his machan, he's his brother-in-law. No. If he lets it off like that, the next judge will quash him. So it has to be evidence. And it is subject to rapid change or obliteration. It will vanish. Things will vanish. I have seen. For instance, a worker falls from a height. He is not wearing a safety harness. Suddenly, before the police come, there is a safety harness next to him. I gave him the safety harness. He didn't wear it. Not in no place in particular. It happens all over the world. It's human nature to cover up and to escape punishment. We are not all noble people to confess. So better to gather and preserve the evidence as soon as you can. The physical evidence includes condition of site, rain, wet, hot, cold, condition of work environment, dusty, noisy, condition of machinery, old, new, even new machines can be dangerous, conditions of materials, permits to work, safe work procedures, supervisors and signalmen's forms, safe work procedures, I've already mentioned it. So it's all based on documentation. Then if you're asked to investigate, in the olden days, we used to sketch by hand. Even today, hand sketching is a skill because photographs may not indicate some of the details that you want to show. So you make a quick sketch. So the investigator must know sketching. He cannot say, hey, come here and sketch this. That is not a good investigator. He must know what he's doing. He must be able to do what he wants others to do, unless it's too heavy to lift and so on. Distances, dimensions, directions must be noted. Broken, even approximate. Broken equipment, debris, samples of materials may be removed for further analysis. Take a photograph, make a note, then remove it and see what is underneath. Don't go and move it up. Oh, I got to see what is underneath. Because how it was covering, why it was not moved, all these will become important. Even if photographs are taken, written notes about the location of this. These days, of course, your cameras record even latitude and longitude. So metadata is very useful to you. But in the olden days, we had to make notes for every picture you took. I used to do that. Then you must remember to take permission. This is something which I have seen happen in the US. Somebody takes a picture and presents it in court, and somebody's face appears there. He can immediately make a stop and say, this photo he didn't take my permission. I don't want, I am not interested in appearing in public or in court. So it is removed from the evidence. So if you're including somebody recognizable, then you must take permission to enter the site, take photographs, talk to person. You cannot say, then it becomes hearsay. These are all legal terms. Suppose you approach somebody and he tells you something. Unless there is a witness, unless he signs a written statement, it has become hearsay and it won't be admitted in court. So whenever I take up an accident investigation, my thinking will be, can I present this in court and not be beaten down by the other lawyer? Conduct tests at site, take away samples from site. Then this is the most important thing. Suppose you find something as an investigator and you think it is valuable evidence. You cannot take it home. Before you collect it, you must have a witness or you must have a photograph. And then you must put it in a plastic envelope, write the location, write the time, and get somebody to witness it, and then give it to an authority. You take it home, it is not custody of evidence. You hand it to somebody, it's not custody of evidence. You leave it on a table and go to the toilet and come back, somebody could fiddle with it. So this chain of custody of evidence, many cases are lost at the last minute when they see timeline for that gun or that bullet. Okay, what happened to this 5 minutes? Oh, I went for a cup of coffee. Gone. In those 5 minutes, somebody could have substituted it. Sorry, it was locked. Any lock can be broken given enough time and enough incentive. Anyway, I'm talking probably too much about every line, but I'm so passionate about this because I have learned a lot. Techniques of forensic investigation. This I give a whole day on it, but today I'll just mention the names. Back analysis, that is something has happened and you go back step by step. It's a retroactive investigation. It's not like writing a movie and scene 1, scene 2, scene 3. From scene 4, how did scene 3 reach scene 4? How did scene 2 reach scene 3? So it's back analysis, and especially in geotechnical investigation, it's very important. In fact, you don't know the properties of soils. Many times the accidents reveal the true property of soils which you have assumed wrongly. Many times an accident shows you something which you did not include in your computer analysis of structures. Then rebuilding. For instance, put back together whatever was broken. Then you may see which one was bent or broken into more pieces, which failed first and so on. Simulation. Simulation can be physical simulation or computer simulation. Simulation is imitating and creating a similar situation. For instance, you can simulate a scene by actors. Many times you see a video as if it is very real, but it is actors. Who is holding a camera expecting an accident to happen? These days, CCTVs, of course, are your best friend. So many things, many times, today's police and doctors have a very easy life compared to the days I grew through. Because today, somewhere or other, some serial, some story, some movie, that CCTV, this CCTV, and then you capture the victim. And in America, they're very familiar with CCTVs. The robbers come with face masks and they wave to the CCTV. But even there are techniques available today where from the eye, the eyes they have to keep open. They enlarge the eye, they pixelate it, and they do some magical things with it, and you can even see reflections of others in the area. I'm talking too much because I'm so excited about what is possible. in forensic image. Simulation is a very common thing. I have done a lot of it myself. Reenactment, of course, this is risky because you are talking about putting people into the scene. Reenactment means, suppose two people fell down somewhere, you cannot make two people fall again. So reenactment is for not so injurious, not so risky things. You can make them. Yeah, show me how you walked, then these actors will walk. Was it like that? No, our shoulders knocked at each other. So walk so that shoulders knock at each other. Could it have toppled this pillar? So that is reenactment. Then you have, if the investigator decide to rebuild or reenact, it must not result in a repetition of the damage. Reenactment means don't repeat the injury, don't repeat the damage, only repeat the action, so that you can see the reactions, you can see the movements, you can see what causes a shadow, so he did not see where he was going. So that is like that. So stuntmen are often employed for reenactments. Root cause analysis, in fact, is a very interesting subject. How do we find what could cause an accident? There are many, many methods. I may not have time to talk about it. Fishbone is a very common. Ishikawa, Japanese scientist, thought of this. And it's very commonly used to go backwards from accidents to find, could this have caused it? Could this have caused it? Could this have caused it? Then there is another method called what if. What if this had caused it? Is the logic correct? What if this fell first? Then should it not have been below? How so it is above? So it could not have fallen first. So what if? What if is asking many, many, many questions, and the answers will focus on what could have gone wrong. Even then it's not proof. Then there is a bow type method or a butterfly method, which puts the causes and consequences together. Of course, my center teaches all this, and you can find it in Google, but today I'm just mentioning them. Then this is a very, I have been an expert witness. Who is an expert witness? A forensic engineer investigates accidents. But then it has to be proved in court. Not all forensic engineers are capable of presenting it in court. Not all forensic engineers are competent to present it in court. Because to present it in court, as I said in the opening remarks, you need to have a very good background of whatever you are talking about. You can talk about anything, but you must show. Is your PhD in that? No, sir, my PhD is not. Then why are you talking about it? Oh, because I worked in this company and in this area. For how long have you done this? One question a lawyer may ask you is, a 30-year-old American lady fell in a tourist spot from 20 meters. So suppose I go as an expert witness. The other lawyer will ask, have you had experience of 50-year-old American lady falling 20 meters? No. No, but, no buts. Yes or no? No, Your Honor. You cannot say no, sir. No, Your Honor. Then why do you feel qualified to do that? Okay, this has happened. So I say, I investigate accidents of 50-year-old Asians. I've seen accidents of falling 20 meters by others. And I've seen accidents of Americans and Australians and so on. So I put it together, and as a person with enough scientific background, I am able to put it together. The judge will rule, okay, you are qualified as an expert witness. If you cannot say any of these, goodbye, thank you, sir, for your time, the next witness. So, not all, and then when you stand as an expert witness, they will tear you to pieces. I wish I could spend the whole hour or so on expert witnesses, but I don't have that luxury. So believe me, you got to have guts, you got to have a good way of responding without getting angry, without getting upset, without getting nervous, without perspiring, and without making jokes. You cannot go to the extent, don't do all that. You're supposed to be a serious scientific person. Anyway, that is out of my agenda for today. If a deposition is taken, then maybe there could be his witness's credibility will be checked, And then deposition is not in court, but privately in front of two witnesses. And they can ask very, very large number of questions, very sensitive questions. In fact, in America, where were you on Saturday night? I was at this bar. How many drinks did you drink? Only once. You expect us to believe that, huh? Saturday evening, you drink one drink? No. How, is there a proof that you see how the things will go? Suppose in America, for instance, suppose one was divorced recently. Then they'll say, what was the state of your mind? Your wife divorced you last week. How do you think you are capable of judging this? Don't go there. Meaning, I don't want to frighten you, but it's a very challenging. And when you feel on top of it, you feel so good. Trial testimony anyway, I will not talk about it again, another talk maybe. So forensic engineer is unique position of not being part of the dispute. A lawyer has to argue for his client. A forensic engineer as expert witness has no client. Even though one of the parties will pay, he's not expected to prove his client is innocent or guilty. He presents scientific fact. If he misses it, if he argues prejudicially in favor of one side or the other, he'll be kicked out. He will become the laughing stock of the entire professional community, and he won't be called as a witness or an expert again. Anyway, if both sides agree, they can have a mediation and so on. And he must be non-partisan and pursuing truth. Satyameva Jayate is applicable to forensic engineers. Maybe it should apply to all engineers, but they all have agendas. He cannot. He or she is often treated as amicus curiae, friend of the court. He is supposed to be a friend of the court, not a lawyer for the one side. So I will now take a little time on famous, or maybe it's not famous, notorious, wrongly famous structural failures. I'm limiting myself to what is well known. Maybe many of you may also know that. I'm putting it chronologically. 1940, before that there were, but not enough forensic engineer. This is a famous bridge, Tacoma Narrows Bridge. It was not incompetence, it was not negligence. And the design was state of the art. So it was a very good bridge. It was built well, designed well as far as the knowledge that went, but it was simply insufficient knowledge at the time. Nobody is to blame. But they found out what the problem was. The problem was something they had not known. Resonance of flexible structures under aeroelastic flutter, vortex shedding. When something is moving, the wind becomes a vortex like a spiral, and that makes a resonance oscillation. Anyhow, it was not known at the time. After that, a lot of research was done. Luckily, no human life was lost. And failure led to significant advances. I'll show you a 1-minute video on how it went. Just 1 minute.
As you can see, this bridge was exceptionally long and narrow, over half a mile long, only 39 feet wide. It lasted just 4 months.
4 months.
Here's opening day.
And then the gust started.
On November 7th, the bridge suddenly went into a twisting motion. The wind speed was a steady 42 miles per hour. This was enough to keep the bridge oscillating in one of its natural modes of vibration with a period of 5 seconds.
Real time.
It's remarkable that the girders were this flexible. This is photographed at normal speed. However, a collapse was inevitable after a little more than an hour of this.
Collapsed.
As you can see, this bridge was exceptionally long and narrow.
Okay, the reason I showed that was not how exciting it is. That was in 1940. 60 years later, a similar thing happened. In spite of all the computers, all the technological advances we had made in 60 years, Still the same ignorance, not the same similar ignorance. In 2000, the Millennium Bridge in UK, in London, was opened by the Queen. It was designed by world's top designers, built by the world's top erectors, contractors, and the Queen cut the thing and watch what happens. It is just half a minute, but watch. This is opening day. Just after so much knowledge, it goes to show that human beings are catching up with nature and with the world. There will never be a time when we understand everything, because then we won't be human. So it took them 2 years and 5 million pounds to correct it. If that was vortex shedding, this was called synchronous. They give nice names after they find something, but it shows that human beings are still chasing reality, trying to find the truth. But now they know. So it's very costly. But in this case, they had no excuse, because horizontal resonance had been documented from 1970s. They didn't read the right papers. It depends on luck also. If they had read one paper, they would have put it into the mix, conducted a risk assessment, and done some calculation. So I will show you a few more, and before I go on to my own stories. Then this is UK 1968, 23-story apartment, East London. It's very simple. It's an RC structure, okay? And a gas leak on the highest floor blew out the wall. It was a precast building. So the walls were precast, the slabs were precast, they were connected, supposed to be connected very integrally by in situ concrete. But of course, like human beings, they found newspapers inside the concrete. Don't worry, it happens all over the world. It may not happen again, but it happened then. So when it blew out the wall, the ceiling could not support itself, it fell down. The connections were very bad. When it fell on that floor, twice the load and shock impact factor, the next floor fell. So it fell floor after floor after floor, and the entire floors collapsed. Very embarrassing. They conducted a lot of tests, and to give them credit, 4 died and 17 injured, but they found that workmanship was not perfect, and no structural redundancy. I'll take a few seconds to explain this. Redundant means extra. Now, I'll talk to you honestly. If as an engineer, designer, I tell my client, you know, this 4x8 steel beam is enough, but I suggest we give 5x10 so that we'll have something extra for emergencies. He'll say, goodbye, I'll go to somebody else. So what we are fighting today is the competition is so bad, people are talking about first decimal, second decimal places, chopping off here, chopping off there, minimum cost and maximum safety, maximum strength. Yeah, it's not possible. Public must be educated that unless you pay for safety and a little extra, you are living marginally. You are getting exactly, if it is 100.0, you get exactly 99.9999 or 100.0001. I'll show you an example where redundancy saved an entire building and saved thousands of lives. But today it's not going to happen. Whether it's America or India, redundancy is a bad word, but bad workmanship can be corrected. And it led to major changes in building regulations covering safeguards against disproportionate collapse. And all that happened. New buildings and war stories were supposed to take even the explosive charges, and existing buildings were allowed a little bit less. And then, because one block was found to be bad, they felt that we cannot trust the others. All the 9 blocks were demolished. Of course, the contractor lost. Maybe the insurance covered most of it. But look at the brave decision they took. Contrast it with a common practice. I won't mention the country. A common practice of a building designed for 3 floors. And after that, his new buyer adds 2 floors. His son adds 2 more floors, and then there's a collapse. So they demolished all of it because they didn't want to risk it. Coming to computers. I was with mainframes in 1959 in the US. So don't think because I am old, I don't like computers. I love computers. I spend 6 hours a day with computers. Okay. So this was the first 3-dimensional truss design program by computers. I have done similar things because in those days, there were no packages. There were no teams. Most of it was a one-man show. You wrote the program, you punched the cards, you took it to the computer center, you checked the answers, and you proved that your answers were right by experiments and so on. So this one-man show or 2-man show produced a computer program in 1970s. That was when 2-dimensionals were fairly established. 3-dimensional programs were just coming into vogue. So there was a stadium, and for the roof, they used this 3-dimensional pod. It's like a pyramid, inverted pyramid, and all these put together for a 110 meter by 91 meter space frame. It's not a plane frame, it's a space frame. And it served for 5 years. It was built in 1973, served well for 5 years, but somehow on 1978, overnight, it collapsed. Just a few hours in the evening, there had been a huge game and thousands of people were sitting there. Somehow they were lucky because if it had collapsed when the stadium was full, it would have meant thousands of people would have died. So their karma was okay. So how did it collapse? It collapsed due to snow load. That is the obvious cause, immediate cause. Overnight, there have been slows in the previous years, but why didn't it fail then? But somehow due to a combination of cold temperature and snow accumulation, the load became more, but that was not the problem. That itself was uniformly distributed, but it started melting. When it started melting, the water gathered in the center. So a small deflection, water gathering means more and more deflection. Instead of being flat, it became curved. Instead of being a flat plate, it became a dish. Collapse because all the pyramidal effect accumulated there. So reasons, many reasons. Structurally, for instance, if I gave you 4 angles, how would you put them together for best effect? Common sense tells us it should be square. But for some reason, probably thinking of connection being easy, they put it exactly the other way around. Instead of putting it this way, they put it this way. So that meant that the moment of inertia, the radius of gyration were all very small. So that was one reason. Then the overconfidence in the computer program. Even today, especially the younger generation is so confident about computers. They are thinking computer is better than my mother, my father, my teacher, Mata, Pita, Guru, Devo, beyond everything. These were written by human beings. Whenever human beings write it, it cannot be perfect. I'm not against human perfection. But once you become perfect, we reach a higher plane anyway. So they assumed that because the computers did things fast, what they took 1 week, it did in those days 5 minutes. Today, it will take 5 microseconds. They thought it was, terrible, tremendous, not terrible, terrific, tremendous. So they believed in it. And it started warning them. I almost give a soul to structures. I say the structure is screaming, trying to tell you something. I'm going, please help me, please save me, or please get out. Even if I die, I don't want you to die. That's what the structures tell you. But we don't listen. It has happened in Singapore. It has happened in Bangladesh. It probably is happening in India. Why probably? I know it is happening in India. Structures try to tell you where they are going to fail. You listen to it, correct it or get out. Okay, so they didn't listen to it, they ignored it. Now I put it in red. The most obvious, the root cause was the fabricator did not follow the design. Today also it's happening. A designer does something. Maybe he's right, he's wrong, maybe it can be done, it cannot be done, but the fabricators don't tell him. The contractors don't tell the designer. They know, I know, I've done this 20 years, I'll take care of it, sir. Don't worry. And then it collapses. What did they do? This was the design. Okay. I think one reason they made the cruciform rather than the square was that the connections were easier. So the designer had thought a connection at an angle can fit within this, and then the center lines will meet. But the fabricator said, no, all this cutting and shaping, why would I do that? I'll connect it to an extra extended plate. It's only 5 centimeters, 2.5 inches. No problem. I've done this before. He did it, and look at the numbers. The design is B, the design is A, fabrication is B, and they built it. Look at the allowable force in the design was designed for 160,000 pounds. But once he moved it, it can take only 15,440, 1/10 of it. 1/10 of it. And it put in moment because it's eccentric. Similarly, second, third one, only the fourth one, there is no change because it happens to be symmetric. So you see the problem? And this is going to happen again. I got 1 or 2 more cases of that. So that is the reason. And after that, of course, they found, after analysis, they blamed the program and they blamed the people who said, don't worry about the deflections. The computer program has said that, you fix it somehow. So this was the way they went ahead and did it. 3 outcomes: the compression members, the fabricated ones were overloaded, the compression members were overloaded, then all the members were overloaded because of the shifting of the connections. In addition to the design errors, there are bracing. Bracing is to prevent a long buckling length, you brace it in the middle so that your load capacity increases 4 times. I think you know that. So midpoint braces were omitted because bracing was not considered that important from a computer program point of view. So they merely followed the computer program's directions and forgot their engineering background. Then the bracing, instead of 15 feet intervals, they put it 30 feet, and then insufficient bracing. So all these put together, depending too much on the computer analysis, I am trying to share some lessons. Computers, however, are only as good as their programmer, as good as their software. And one shouldn't be too arrogant that he has done a good design. It depends on the software. The roof was extremely susceptible to buckling. These are Martin and Petrovsky authorities. Their opinion was that the program, at that time, you cannot blame them. It was one of the early programs. Then we have become smarter. We have become smarter because of failures. Remember that. Impact of the findings, the collapse shook public confidence in the space roofs. Public was thinking, oh, the computer is a blessing. Huh? It's panacea for all ills. It's a blessing to mankind. I want my children to learn computers. The computer is the silliest, dumbest machine in the world. It can only count 0 and 1. It's the programmer. It's the program. And programs have been gradually improving over the last 30, 40 years. Today, almost all programs are as near perfect as the existing knowledge goes. But unfortunately, I'll point out some limitations. President Ford of the United States said, this is one example, let us check all the other things and let us do water load testing when there are no people present. And then they said, let the programs grow slowly. That's what they did. Okay, then the lessons learned, of course, I'm repeating, ensure that the computer analysis covers all the modes of failure. If it cannot, check out by conventional methods. Very unfashionable, very unpopular. I tell my class, Okay, you got a software program. I'll give you a simple example. You do it by hand. By hand? Me? I know I can do it in my this small work laptop. Why do you want to? I wrote a book on computer graphics. My nephew tells me, Uncle, why did you write a book on computer graphics? I touch C, I get a circle. I put R, I get a rectangle. Why do I need it? So if I ask you to draw a rectangle 3 inches by 5 inches, what will you do if you don't have a computer? I won't do it. I don't want a rectangle. God help them. God help them. I learned this in the United States, not in India, not in Singapore. If you want to get something done, regardless of time, unless it's a very complex thing, at least the simple version of it, you must be able to do it by hand. Including sticking up strain gauges on a specimen, structural specimen. When I went to USA to do my PhD, I looked for Professor James Chin, who was my guide. So I go to the office and say, I want to meet Professor Chin. I was sitting a guy with tie in an office. He said, down in the lab. So I go down to the lab, and there I don't see anybody with a suit and a tie. So I asked the technician, I want to see Dr. James Chin. He shows me on the frame about 4-6 feet high, and he's sticking something in a brown overall, not in a suit. That is James Chin? Yes. I learned then, of course, you may call it the dignity of labor and so on, but I learned that if you want to get something done right, you must know how to do what your assistant is doing. That is why even today I write Excel programs. I wanted to write a book on welding. I did some welding, not very well. Of course, my situation is different. What I'm saying is, check out by hand one simple example of anything you want to do. You want to calculate the moment of inertia of a complicated thing? Try to review your background, do one simple thing and see if the computer gives the same answer, and then let the computer do it. Anyway, I shouldn't sermonize too much. I got so many more slides. When any change is made, analyze, reanalyze. Hartford, Connecticut, America, forgot that. Singapore, in one particular case, forgot that. People forget. One analysis, they get a beautiful design, and somebody makes a change. Oh, that's just a small change. You are going to see one small change killed 114 people. And the change looks so logical. If I ask you to say that's okay. Instead of 10, I put 2 into 5, 5 plus 5, it's the same, isn't it? No, it's not the same in construction. Heeds warnings. This is the third lesson learned. The structure is trying to tell you something. It happens again and again and again. In Singapore, very rare failures, one failure, the structure has been screaming for the last 3 years. Cracks on the wall, patched it up. Tiles fell, bad tiles, stupid fellow, put new tiles, get insurance. Column broke. If it had a voice, it would say, I have been trying to tell you, I'm not strong enough to take all that load. Somebody made a mistake in design, killed 30 people in Singapore. Beware any change and warning sign, listen. It's trying to tell you something. A child doesn't cry unnecessarily. When it cries, either it is hungry, or it is sleepy, or there is a small thorn in a cloth. Better find it. So treat it like a child. Now, 1978, by then computers had made some progress, and scaffolds had made some progress. It was a new scaffold system. Cooling tower, as you know, is necessary when you use a lot of power and a lot of hot gases are escaping in your energy production. And so you want to cool it, you put water in it and let the water flow up, and then it cools in a certain area so that you send cooled water outside. And this is the cross section. This is a typical cooling tower, 2 of them. The second one was being built with a new scaffold system, which they were not familiar with. And then suddenly on one day, when it was at this level, and it's again another small video.
Our scaffold and construction system began to collapse as the top layer of concrete crumbled. Starting at the north end of the tower, the concrete and scaffold peeled off in both directions, detaching from the rim and falling inward. Our scaffold and construction system began to collapse as the top layer of concrete crumbled. Starting at the north end of the tower, the concrete and scaffold peeled off in.
So on investigation, they found many, many problems. When an accident happens, you must allow a detailed investigation and you must document everything so that we can learn and others can learn from it. Unfortunately, most of the information I get is from America, next from England. Japan has lost lots, but it is in Japanese language. Australia is okay. Singapore is very good. Of course, it's a small city, 4.5 million, 5 million. 51 workers were killed because they were all working on the farm work. And then 2 or 3 problems. One, the supporting this farm work was supported on the bottom layer. They removed things too soon. They did not connect it properly, and it had not been cured to the correction. Too early removal of farm work. Then they were not familiar with the farm work and repositioning with the ties. They moved the load pickup point a little farther off. It caused more moment. Not all the way around. One point, it's enough. It's a domino effect. One failure, it encourages another failure. This is probably the most famous case in the world. Probably everybody who talks about forensic engineering does this. I'll try to be brief about it. 1981, this was a very famous hotel and very fashionable. And one night, after a few years of building it, one night there was a dance, and on the corridor in front of the rooms, people started dancing, and it collapsed. And on the left-hand side, you see the collapsed portion. And the point was very, very simple. The contractor, the fabricator made one change. Remember Hartford? Similar thing here. There at least it was complicated. Here it was simple. This was the graphics of what it was. Level number 1 at the bottom, man walking. Level number 2, level number 3. That is floors 2, 3, and 4. They were on opposite sides. These two were suspended by design by one rod. This drawing shows 2 rods. One rod from ceiling to the top balcony, top floor, and then the other rod from the top to the bottommost. So this was the change. The original was a single rod. Through this, threaded all the way, because the nut had to go all the way from bottom to here. But after the failure, you notice this, the left-hand corridor is here, but the 2 right-hand corridors are down on the floor. This is the morning after the event. So what had happened was that this is a disaster area. This is the bolt pulled through and channels pulled through. And this was the simple substitution. Originally, it was a single rod. The nut had to be turned all the way from the bottommost floor to the topmost floor. That was the problem with the fabrication. So he simply substituted one rod from top ceiling to the top and another rod from the top to the lowest. What did that do? I don't have time. I put it to you as a challenge. Prove that you all are engineers. Most of you have had statics and then free body diagrams. Prove that when you moved from 1 to 2 rods, this nut was to take 2p. It's correct. I give it to a PhD. If they are not looked at it, they will be confused. But it's very simple. It can be taught to a high school student. I leave it to you. If you do it without consulting a book, you can rate yourself as a good structural engineer. In Singapore, 1986, this is called Little India because it is mostly Indian shops. I don't think that was the reason. But they had a building built in 1971. 15 years it served. But it wasn't fully occupied. It was occupied slowly, floor by floor. And as the technology developed, They brought in more and more equipment, more and more machinery, air conditioning units on the top. And then the bank wanted one whole floor. So the bank brought a steel vault, very heavy, tons, and then they put it there. It collapsed. On 14th evening, it looked like this. On 15th morning, it looked like this. Early morning, the whole thing pancaked. It didn't fall sideways. It fell floor by floor. This is all you see. It's buried in the basement. 100 and odd people were trapped in the debris. 33% died, 17 were injured, the rest were rescued. And in Discovery Channel, National Geographic or Discovery Channel, there is a 1 hour special. I recommend that you see it. It's free during the weekend. Heroic, it could be a movie like a Titanic. Foreign companies who were working dug tunnels from the sides to rescue them. People sent oxygen, glucose water, and medication through tubes to the people trapped below. It was, anyway, I don't have time, but the reason was it was designed by a draftsman who was not qualified. And this draftsman, God bless his soul, he's not around anymore. He simply forgot to include the dead load. How it survived 15 years is a miracle. I told you, because it was not occupied fully. So if it had been occupied fully the first month, it would have collapsed then. And because of the new additions like the AC compressor units on the roof and the bank vault in the 5th floor or something, it collapsed. And this is the example I said, the columns shed their tiles and people just patched it up, put new tiles, and it would break again. And they blamed it on the tile, not on the column. Mistake? Yeah. Okay. So this is another example. I have to rush through. This is an example of a oil and gas production platform. It's called the Sleipner platform. Famous, sad, because it cost $700 million. Luckily, I don't think there is any loss of life as far as I can remember. And this was a computer problem. Not a computer problem. The computer never makes mistakes. The program also was not a mistake, but finite elements is a sensitive thing. I grew up with it. My master's degree paper was in finite elements. I know the initial programmers. The father of civil engineering finite elements, Ray Clough, has come to my home and eaten chapati with me. So I grew up with finite elements. I know its power and its limitations. This used Nastran, one of the biggest programs even today. It's not the fault of the program. It is the fault of the input. There are two dangers with finite elements: input preparation and output interpretation. I have no time, but you study finite elements, you will understand. Today, you press a button, it does it for you. You don't know what it does. You get numbers, 6 decimal places. So the mesh was too coarse. I cannot go into details, but the finite element, first you must decide how many pieces you break it into. And for some problems, 100 pieces may be enough. For some problems, 10,000 pieces may not be enough. If it has stress concentration and so on, it's a separate subject. You must be really paying attention to it. Don't jump to it. Don't take anything responsible until you're sure of what you're doing. I am fairly sure of what I'm doing. I am very basic. I worry about the basics. The rest of it, the computer would take care of. But preparation of the computer model, preparation of the input, I take very good care. So today, wizards, magic, you put 1 or 2 numbers, it gives you a bridge. Don't be too happy. You don't know what the bridge is doing. Now, the next few slides, I cannot spend too much time. It's the very famous World Trade Center collapse, the terrorist attack on the 2 towers. So you can get enough in the website, but I'm going to touch only on what I'm aiming at, redundancy. Okay, I'll tell you why I'm saying that. So tower number 1 at 8:45, a fully loaded plane, terrorists took over the cockpit, disabled the pilot, and drove it directly into the North Tower. They died. They were willing to give up their lives, but they also killed all the passengers, and cut all the columns. It stood bravely, I'll tell you. Then another plane took off, and then about 15 minutes, 20 minutes later, it hit the South Tower. Again, terrorists, they didn't mind dying, but they killed hundreds of passengers. And it was a very bad situation, and many people learned a lot. And from then on, terrorism has become a problem. The structure with all the columns, most of the columns cut, it stood for 103 minutes. Brave structure. It gave its life to save thousands of lives. Second one, somehow it collapsed. This second hit stood for a shorter time, half the time, 53 minutes. Even that stood for nearly an hour, allowing people to come down in the many, many flights of stairs. And it probably held 10,000 people. 7,000 people walked out of it alive. 3,000 people could not and were crushed into paste. People blamed the structure. In Singapore, somebody made a joke. You structural engineers cannot build a building to withstand an airplane attack. I couldn't help it. I couldn't resist it. I wrote back saying this. You want me to build a building to take a terrorist attack? You tell me, I will build it. You want me to design a building to take an earthquake of 8.3 and you want a 100-year life? I can build it. But the columns would be 3/4 of the floor area. The slabs would be half the height of the building. Are you willing to pay for it? Where will you pay for it? Where will you pay the money? Our structural designs have to make a balance between functionality and utility. It's not a luxury. We are not like kings who had all the materials at their command, all the workers at their command. So we are limited by our resources. So don't blame the structural engineers. He said, did you design it for an airplane? Yes, we designed it for an airplane. Because New York is in the middle of 3 airports. And those 3 landing, we know in terms of at night and maybe on a foggy day, they will miss their direction and hit a building. We designed it. Then why did it fail? Okay, now you are coming to realities. A landing plane is coming at about 100 kilometers an hour. And its weight is half the initial weight because the fuel is half the weight, 1/3 the weight. So when a plane takes off and hits it, you are having 2 problems. One, the weight is double the design weight, and the speed is 400 kilometers an hour, 4 times. So if you need a factor of safety, 8 times to 16. Are you willing to pay for that? Now you tell me I didn't design it for a terrorist. Tomorrow, can you design it for a terrorist? All you can do is to put steel blocks so that the cars will not come in. You cannot stop a plane. Of course, the planes will be alerted and fighter planes will shoot it down. That is another matter. So what I'm trying to say is structural design is a balance between functionality, safety, economy, and practicality. You run a risk. When you cross the street, you run a risk. It's a known risk. We design it for what you want, what you can afford. And you're cutting our fees to the bone. How can you give you good structures? Anyway, that was a good exchange and people shut their mouth. But then after that, they are giving more and the fireproofing is increased and so on. So I'm not going to show these slides because what were the main causes? Too large, many times beyond design loads, too hot a fire. What happened was in a landing plane, the fuel will be very little. This was fully loaded plane, so all the fuel dropped into the lift core. So it became a tank of fuel. And the fuel, this lift core acts like a chimney. So when the fire started at the bottom, the fire grew up, suddenly a lot of temperature, high temperature, and through all the beams, even though it was a reinforced concrete building, it was supported on steel trusses, the steel melted. Don't blame us, blame the terrorists. So did they design for such contingencies? I've already explained. We have designed for a normal accidental impact, not for a terrorist. You cannot afford to do that. Why did the floor, all the floors fell like this? Not like this. Why? It was designed to fail that way. Because if it fell sideways, a 10, 20-story, 30-story building will destroy half a dozen buildings, still thousands more. So the towers were designed to pancake. Pancake is dosa, like dosas, like set dosa. Thank God they only killed 3,000 people. If it had fallen sideways, it would have killed 10 times more. Okay, some more, I think I'll skip this. Collapses, again, authorities, Shyam Sundar, an Indian settled down in America, he analyzed it, and there are beautiful computer graphics things on this. I don't have time. The result of a combination of factors. While the buildings were able to withstand the initial impact, the resulting fires melted the steel and collapsed the concrete. Okay. Now, this is the point I want to make. How did it stand 103 minutes? This brave building. How was its arms cut off, legs cut off, but its body still stood, allowing the people to go? Redundancy. The owner knew he was putting in more money for redundancy. He probably didn't think in terms. He said, I want to stand at the window and I want the full view. I want to see New York, my city, from any floor. That means he doesn't want the window. He wants entire glass from top to bottom. Then who is going to carry the load? Aha. The designer put columns, mullions. The sides of the openings were called mullions. Even the sides of windows are called mullions. The sides of the openings were steel columns. They took the load and they resisted this high temperature for 103 minutes. That was redundancy. He didn't need so much. If he had left the openings and distributed load from lintel and around and into the sill and then carried it, he could have done it for that portion, he could have done for half the cost. So, but today it's a very unfashionable thing. I cannot suggest to my client, you put 10% extra because you don't know how people will treat this building. They may mistreat it. So, no. I will treat it nicely. You give me the minimum. That's it. Okay. I was lucky. My student, Mr. Nagaraj, was the chief engineer for the Metropolitan New York. My students have Narayan Murthy, Nagaraj, so many people are in high positions and they invite me to view. Nobody could get into that site when it was cleaned up. It's called the bathtub because it was shaped like a bathtub. The two towers had been spoiled and they were planning two other towers. It's now built and in full swing. So he called the engineer who was cleaning up the site and said, my professor is coming, help him. I climbed down, I think 120 steps. It was tiring, but it was 15 years ago. So I was much younger and stronger. And that's me on the right-hand side. On the left-hand side is Jack Donnelly, project manager. So proud. And it is nice to meet those people. And when I stood there, part of me said, 3,000 people died here unnecessarily. They couldn't even get enough for their DNAs because they were ground into tomato paste. Anyway, it's sad. Now, one thing from Singapore, Nicole Highway collapsed. It was a highway, you can see in the right of the picture. And it had been designed by the latest software, by some of my own students and friends in the universities here. Everything was okay. Suddenly, one day, the wall collapsed. It was a sheet pile wall, and it was collapsed. A commission of inquiry made up of international experts, 12 or 15 experts from all around the world, came and investigated it. The final report was 1,000 pages long, and it made many changes. They threw out the Factories Act and then reintroduced a new act called the Workplace Safety and Health Act. I have been with the transition for the last 20 years, and I'm teaching the changes and so on. How it happened was, the schematic is given on the right-hand side. The two side walls are sheet piles. Okay, so as it was dug every 5 meters or 10 meters, they put a strut to keep the walls in position. Because the earth pressure would be moving them in, they kept it apart by what they call strut veiler. It's called wale, W-L-E, or veiler. And then as they went about 30 meters, the pressure became too much and it collapsed. And you can see the collapse in the left photograph. And then the investigation started. 4 dead, only 4 dead, luckily. 3 injured, luckily again, because it was probably lunchtime and so on. Causes under design of diaphragm wall. It can happen today in Singapore, which is one of the richest, and it is number 4 or 5 today in the safest countries in the world. It has many iconic structures, worldwide acclaimed. Under design, I'll tell you. They depended on a computer software. Latest version. You know, I taught computer software for Hong Kong many years ago. So the night before I left for Hong Kong, the manager calls me and says, "Professor, you are giving us version 8, right?" "No, I'm teaching version 7. "Professor, we got version 8 last week." I said, "How many commands of version 7 have you used?" "Oh, about 32. "Do you know there are 100 commands in it? You used less than 1/3 and you want to go to the new version. It is like buying a cell phone and using just photographs and texting and selfies and going for a new cell phone. That is the fashion today, but it doesn't work that way. The first versions of any software today are worth paying close attention. Study the input. You won't study the manual. There is no written manual. It's all on the website. You won't read it through it. Probably it's 500 pages. But study the input manual. So this particular version of the program they used had changed the model A to model B and created a new model A. All my own brightest students were professors. It can happen to me if I'm not careful, but I learned my lessons, you see, so I won't take it at face value. I never use the latest software unless it has been checked out and found mistakes in it. Anyway, that's my philosophy. So they used it and it gave deflections which were not reproduced in practice. So that was the problem. That is, the program was not wrong, but the input to the program was wrong. So that is a human effort. Don't blame the program, don't blame the computer. It is us. Then that is why in the bottom right figure, you see the flange has been bent here. The compression flange of the H beam, horizontal I beam, has been bent. And then you see the web has been bent in the right arrow. So these are things which was not reflected in the program because they used the wrong model. Anyway, again, $200,000 is nothing. And senior executives were fined. This may look a lot, but how can you compare it to 4 lives? How much is a life worth? Sir, it is worth 2 lakhs because that's what the government pays every dead train accident. 2 lakhs. You create a life for 10 crores. So it led to the new Workplace Safety and Health Act. Lot of learning there. And then Nicol Highway rooted in 2 critical design errors: under design of the diaphragm wall, under design of the Whaler connection, and not listening to the warnings given by the readings. It was very heavily instrumented because it had lots of money, you know. It's an iconic thing. It's a world famous Nicol Highway and we are doing this. So everything was instrumented. And the instrument told them your deflections are high. Anybody would have listened. But the confidence in the program, the confidence in the PhDs, the confidence in the dozens of papers published, that program has met world acceptance. For the last 10 years, we are using the latest version. But my friend used the wrong model. Who is to check you if you don't check each other? And why don't you listen to the screams, the cries that the instruments are telling you? If it says the deflection is 27 millimeters and your computer program said it should be 14 millimeters, don't you suspect something? No, the instrument could be bad. Maybe he read it wrongly. It's all documented automatically. Anyway, people make mistakes. Even the brightest people make. God help me, I'm not him. But for the grace of God, I could be him making that mistake. Each day I come out of a successful case. I thank God. Don't enter it. Don't undertake unless you are sure, unless you have control, unless you take the extra time beyond what you are paid to check out some way different from the program. Anyway, I think I'm sharing a lot of what I learned. Collapse develop progressively. Failures to demonstrate the necessary level of care. The ground people reported everything. It was never the worker's fault. It was never the supervisor's fault. It was never the instrument man's fault. They reported everything. It was the middle management that missed the red flag. Of course, this international committee found who was to blame. You know, at this point, I got to admit, what may look right to you and me as a citizen may not work all the time. There are two barriers. One, the court. The court must prove beyond reasonable doubt, any fraction of doubt that is correct. What the person to blame or the cause to blame is correct. Second, is it good for the country? You see, that is very delicate. I'm not going there. I won't call it politics because politics is selfish. But there is something beyond that. Is it good for the country? Is it good for the government? Will it topple the government? Will it put blame and people will suspect and it will cause more problems than we accept what we are? So anyway, there are many, many reasons. Serious human errors, warnings of approaching collapse, not taken seriously, and so on and so forth. And builders' inadequate capacity or ability to read the warning signs, multiplicity of signs, and then failures of the defense systems, meaning there are no backup systems, protective systems, no reviews, inadequate remedial measures, abuse of the back analysis, because they should have, when they found this, they should have checked the soil properties and then redid it, because some of the soil properties had also been wrongly judged. I cannot blame them because soils, it's underground. You don't check every inch of soil. You check some bore logs and think that's true for everywhere. It's not true. So there are some things they forgot to do, and then monitoring, critical analysis, and so on. Now let me come to the next ones. Catastrophic. And then these were all the problems that happened. Surging readings so that difficult to keep up with them. Then trespass of water and soils into the excavation. Occasionally there were leakages and so on. Then car bells broke down. So many things which are natural. And more than anything, the workers knew it was going to fail because the steel popping up welds and bending thung noises. And the problem was the safety officer had to come and relieve them. One country's crew, because in Singapore gets people from many countries, they left. We don't care for your jobs. But other people stayed. Luckily, it was lunchtime. Otherwise, more would have died. Okay, collapsed. And responsibility. And you may be sure that the people who were irresponsible are punished, but some of them secretly, because the government will have internal review and they will punish them internally rather than make a big newspaper thing out of it, because it's a small country. And I'm not going to talk anymore. I'm not recommending it or criticizing it. Everything cannot be too open because you must think of public safety. I have another lecture. I'll say how public safety overturns sometimes the obvious things. So I'll pass through this, many unsafe acts. Now one more quickly now. This was 2006, a tunnel in Boston. I've been in Boston. I gave a paper there. A car was traveling with Mr. and Mrs. Delville, who are going to celebrate their 35th wedding anniversary. Suddenly, one roof slab fell on the car. The lady died. Instead of going to a restaurant to celebrate, they went to the hospital and the mortuary. And the problem was, epoxies are always, I won't call them risky, I'll call them a specialized material, unlike concrete or brick or even steel. So the glue that was supposed to hold the suspension steel rod into the roof was epoxy. It was a new brand of epoxy. And to give them credit, they offered to train the engineers in curing them. And the engineers said, no, we have been using epoxy. We are on the forefront of epoxy knowledge. We have used it for 10 years. Don't worry about it. The curing process was different from the other ones. Didn't care. They died. Luckily, it was only one death. They then checked everything and redid the connections. That was one example. Then two funny examples. They are not funny. They are rather sad. China has two extremes like India has. India is probably the best and worst of everything, whether it is corruption or whether it is structures or whether it is, for instance, in space technology and computer, we are better than most countries in the world. So China has very elaborate structures, very complicated structures, things we cannot imagine, automation, so on and so forth. And they are able to produce things which we can produce, but somehow we don't have the willpower to produce. They built a bridge and removed the formwork. The whole thing collapsed. And they found, to their embarrassment, luckily to us, it cannot be covered up. There is no steel reinforcement in there. Almost similar to some engineer forgetting the dead load, this didn't have steel. Maybe the drawings omitted it or the contractor omitted it. When they removed the formwork, it collapsed. Very embarrassing. Killing 36 people. Of course, it's very rare. I won't blame the country. It's just a human error. One more, this is even more embarrassing. You look at all these buildings. This block that is on the ground was exactly like that. One fine morning, it fell over. None of them got broke. The structure was so well designed that even after falling down, the floors were intact. If you could only turn yourself 90 degrees, you could live in it, except water won't flow. And how did it happen? Human error. I can call it engineering error. So this was the building. They wanted to build another building next to it. So they dug it. First mistake. Second mistake, they put the thing next to this building. So double mistake. So here there is excavation. Here there is overload. And so the whole thing was weakened and it fell over. Embarrassing. But as I say, this was a very unusual thing. And of course, there are other things, 4-story building. And here they did, I wish I had time, but this is a very nice forensic engineering analysis. And there again, excavation and insufficient protection to the foundation. I show this because now I am going to Indian situations where most of it are foundation problems. So India, again, I tried to look for records. I found one in 1961 near Pune, and there it was a problem. See, 1961, steel production was not so high and it was too costly. So instead of reinforced concrete, they thought that the ordinary unreinforced concrete would hold, especially in a certain interlocked form. It did not. So that was a simple explanation. They learned by experience. Now I see too many of them to analyze in detail, but I'll show you a few. Mumbai 2013, 2017, every city, it's not just one city, Bangalore, and then West Delhi, Goa, death toll in Chennai. And it was difficult to get full statistics until I found a couple of papers. Gangaram building, I was born in Bangalore. I have gone to Gangaram. They were selling my book on computer graphics. This was their new building in 1983. And again, 123 people died. They had come up to almost the top level when it suddenly collapsed. And then charges were filed and structural violations were found. 7 additional buildings, floors, without a design. 2-storied building was there. On top of it, they put 7. Because in the olden days, you had rock and then you thought the foundation could take an elephant or 10 elephants. So construction plans deviated considerably from the approved plans, as happens even today. All, unfortunately, I mean, this I understand because the judge cannot take sides. He will look at the evidence and he should have, beyond reasonable doubt, a cause to charge somebody with a felony or with a breaking of the law. So the judge found, they went to the Supreme Court, they still found that the Evidence was not collected correctly. You see the problem? When you want to file a suit, you must have proper evidence. Okay. Now, this operation was in progress. And this is the, let me come to my case studies. I got only 15 minutes and I don't know. Again, I'll just flash through another, but this was done very well. This thing in Chennai, Trust Heights, there's a very good forensic study. The original explanation of a collapse was lightning. They had a very convenient excuse. After heavy rains, lightning struck the building and the reinforcement connected everything and broke the concrete and it collapsed. Everybody was said, oh, unfortunate lightning strike, what can we do? Then the forensic engineers came in. The forensic engineers did all the things, structural analysis, the material analysis, impact analysis, every test they did, and I'm proud to say that they destroyed the other building also. They found that so many mistakes were there. And that paper gives me the number of incidents of collapses, building collapses. This doesn't include dam collapses, bridge collapses. Building collapse, which country has? We can boast we have the highest number of building collapses in the world. Highest population, highest number of building collapses. And each building had at least one death average per incident. So look at the numbers, almost equal. Does it mean that only one person died per each? No, in some incidents, nobody died. In some incidents, 30 people died, 10 people died. But these numbers are horrific. We must stop them. So I hope this helps people stop that. But they found the foundations were too weak. Building materials were not checked for quality. There were many human errors. The load was heavier than expected. The strength of the concrete and other things were not tested. Okay. So this is the rubble. I got to only stop here, and then this is very elaborate. I want to show one slide on the costs. The costs that we see and the public sees is just the direct costs. Maybe health insurance, hospital costs, damage, and so on. But there are so many indirect costs, hidden costs, abnormal events, isolated human errors, management system weaknesses, and these cost 5 to 20 times more. So the cost of an accident is not just the accident cost. The cost of an accident is the direct cost times 5 to 20 times. Now, I'll try to rush through this, sorry about that, but I get too excited about it. Now, I mentioned that something does not have to fail. You can imagine the scenarios of failure. So let me rush through my experience of this. I was among the first to do finite elements in USA, and I had already published some papers. So a city close to my university called my head professor and said, we want to set a new sewer pipe because our 60-year-old pipe is insufficient, sewer pipe. So we are laying a new steel one. We want you to check its safety. So, okay, they sent me the details. They were going to bring a crane on top of this old one and lay this. This was their original plan. Okay, so I did a finite element analysis because there is no actual theoretical solution for this shape and so on. So I had my computer at my university computer at my disposal. I created a model and did it and found it was safe. I should have kept quiet. Not me. Because once you know failures, what are the possibilities? What if the sheet pile for the excavation moved away or moved inward? So first alternate scenario, what if pipe breaking under certain conditions? So I said safety, FE analysis was okay, slackening. Suppose the rope or the guy wire holding the sheet pile stretched 1 centimeter or half an inch or something. What will happen? Okay, I checked it. It was okay. I almost told them to continue. At night, I could not sleep. I said I only considered it moving away What if he over-tightened it? That is the what if. What if instead of a natural elastic slackening, he over-tightened it to allow for that slackening? So next morning, I rushed to the computer center, begged them to do my problem immediately and gave a negative displacement, and it showed it will pop up. I called them and said, don't bring the crane there, because whether you tighten or loosen, I am not going to take the responsibility. I do not approve of this method. Come from the other side. Oh, it's another 30-meter drive, professor. I don't care. Either do you do it that way or I am not signing. They did it, and thank God they have got a good sewer system. Then the second one in Singapore, I have done many, but I picked only one or two for the structures. I may not leave 10 minutes for the questions, but let me rush through this. In 2004, after the Nicole Highway, a big 5-meter slab rebar cage collapsed, killing 2 people. I had just returned from another conference, and the commissioner somehow sent for me. Commissioner is like the director of safety in Singapore. He said, I want you to investigate fusion policy. I said, why me? Anyhow, I was probably too modest. He thought from America, everybody comes with all the knowledge. I agreed. And to cut a long story short, there's a lot of coverage, and I took 1.5 years to do that and presented a lot of data. So the actual problem was, this was a re-erection afterwards. So what should have stood straight like this collapsed like dominoes because of lack of bracing. Straight, bracing, diagonal missing, so it collapsed. This was the building, foundation for that building. Then this was the actual collapse scene, and I have some pictures of it. The rescue scenes were like this. People, a cage went down from the top, picked out the dead and the injured people, brought them to the surface. And then I show a few slides. The formula they used was wrong. A PE put his chop to it and signed it. Pi squared EI by L squared is the normal buckling load. He put 2. He didn't know why, because the new recruit had thought that both ends were fixed. How can you fix a temporary structure? Anyway, that was one problem. And then there are so many problems. Instead of giving a vertical support, he gave an inclined support. He said I had longer things, so I put it inclined. I said, by putting it inclined, you are giving it a tendency to move. It should remain straight. And so buckling, everything was wrong. And I took a lot of time. And then the judge and I got along very well. I gave evidence, and the judge said, okay, professor, now he was a civil engineer, incidentally. I have a question. Suppose this column broke, would it have survived? So overnight, I ran a bunch of, now this did not need a mainframe. It could be done on a PC. I had a good friend, and I had this big computer program. So I did whatever the judge wanted. And the next morning, is this all, professor? I said, I didn't sleep last night. He said, do you know, professor, I didn't sleep last night because I read your report. Then I also conducted some field tests. The opposition, the defense had conducted field tests through a university spending $25,000. I did the field test doing $50, including the salaries of the 2 people who helped me. So I don't have time to go into it, but it's very funny because I used a spring balance. Remember, I am also a university man. I know all the instrumentation, strain gauging, and so on. They had spent $25,000. But I used a spring balance, and I came up with a dramatic result. Their estimate of a resistance was about 75 kg. Mine broke at 15 kg. So I presented the next day, and then the lawyer said, you used a spring balance of $2. How accurate is it? I said, plus or minus 10%. He said, plus or minus 10% is 20%, and your results are accurate only 20%, and you are presenting it against a university result, which is plus or minus 0.1%. I didn't have to say anything. The judge said, okay, allow 20% to 12. 12 plus 20% is less than 15. You are saying 75. He has shown 15. Keep quiet. Meaning, you cannot be so lucky every time. I'm boasting because I was lucky. You cannot get off so easily. But what I'm saying is, you must think out of the box. What is your aim? Anyway, I did many finite element analysis, and I spent a lot of money. The government reimbursed, of course, and then a lot of time, effort, help with some friends and with a company I know. And then finally, they found that the design was faulty, erection was faulty, there was no, and I insisted, just like the international committee insisted, that the factor of safety for temporary structures must be higher than the factor of safety for permanent structures. And my wish was fulfilled when I joined the committee for formwork analysis, formwork design code of practice, and we were able to raise the factor of safety for formwork to 2 as against the scaffold factor of safety of 1.5. Anyway, I'm running out of time. So many interesting things. Maybe I should stop here. And about computers, I want to only remind you that number 1, you need to know the program. Number 2, if it is a program and you have an idea, get the help of somebody familiar with inputting the program. I'm not talking about the theory of the program or the explanation of the program, but input. A single digit in a wrong place will give you a wrong answer. You cannot find it when the output is 2 inches thick and you have to examine 2,000 members. You cannot do that. Anyway, I had photographs to help me, how they were not straight, they were already bent, how theoretically they were supposed to tie, and the university in their tests tied every other joint, while in practice there's only occasional joints. All this I was able to prove by photographs at the court, and then they found the other persons guilty. Of course, I had also lots of computer PowerPoint presentations and even a animation to show how they cannot rest one round rod on another rod. See, it jumped suddenly, but I showed it gently slipping here. Anyway, even some other animations I used like that. And of course, I'll skip this. I'll stop here. If there are no questions, I'll show this case. Okay. I'll hand over the program to
Thank you, sir, for your presentation. It is more information input you have given to us. And if anyone have the question, you can interact with us, sir.
At least 15 people attended. Last time 45 people attended, but at least thank you 15 for staying with me and making me feel happy.
No, sir, there are around 22, probably because of network or anything.
Okay.
Most of the time they were there.
Of course, I want the whole world to listen. I want all the Indians to listen so that accidents can reduce. Anyway, I open to questions, please. I am willing to stay with you a few more minutes. It's not me.
Yeah.
It's up to you.
Anyone have the question, please interact with us, sir.
Come on. I want.
If there is no questions, we can.
No. I want somebody to ask a question. You mean there are no questions at all?
Yeah.
That means I have not talked anything. Or my talk went over their heads.
Arpita? Madam?
Yeah, Arpita, please ask. It may sound small or trivial, but believe me, 10 people have the same question. You'll be helping them. I won't, don't worry about my age and so on. I'm like you. Anybody else?
Dr. Pradeep, sir.
Okay. Okay, I give up. No, you're losing your chance. You could boast tomorrow that you asked a question to Krishnamurthy, 90 years old.
Yes,
who wants
sir.
to honor? You mean none of you has the courage to ask me a question? Lakshmi, Prashant Kumar, Elizabeth, Aziz,
Lakshmi audio is not connected. She may not
anybody, I mean, okay, I give up. It's there.
Oh,
It's my loss too,
no,
because I like talking to younger people.
no, Madam has some question.
Yes,
Yeah,
ma.
please
Good
go
question.
ahead. Yeah.
Sir, this is Arpita. I'm a PWD engineer.
Hmm.
Sir, this is not a question, but the presentation is really very good. All the case study, the Twin Tower was one of my favorite. What you explained.
Dangagbutta, stun ಆಗ್ಬಿಟ್ಟೆ ನೀನು.
ಇಲ್ಲ ಸರ್, ರಿಯಲಿ ಆಲ್ ದ ಕೇಸ್ ಸ್ಟಡೀಸ್ ನಮ್ಗೆ ಐಡಿಯಾ ಇತ್ತು, ಓದಿದ್ವಿ, ಬಟ್ ದ ವೇ ಯು ಎಕ್ಸ್ಪ್ಲೈನ್, ನೋ ಸರ್, everything was just connected the dots. All the case studies were really, really good. We are really very friendly manner. You explained everything, sir.
Thank you. At least you responded to my request for some.
Yeah, the audio was really...
Dr. Pradeep Lania, don't you have something, sir? You have a comment or something? I'm so happy a PhD is listening to me.
Comment. Few case studies have a like a structural part of view when you explain the decoupling part,
Yeah.
the column redundancy, what you explained, sir. That part I have a little bit of doubt structurally.
Okay.
Other than that, I don't have any doubts.
Okay, the doubt is natural because people don't build redundant structures. They build exactly what is needed, and even there they make a mistake. Redundancy helps to compensate for any human error in design or workmanship, but it's costly. So, for instance, for space structures where risk is high, for aircraft, you have a redundant program. For instance, in your computer program, they have triple backup or a double backup for planes, triple backup for safety. This is a redundancy. In our situation, we don't have any backup. Either you do it correctly, or if the thing crashes, then you do it again. So that backup is a redundancy. Now, suppose you got a stadium or something standing on 100 legs. Now, suppose one leg at the entrance, a car hits and it breaks down. Will the whole stadium collapse? You must test it. You shouldn't say, oh, there's policemen. We got put bollards around it, so nothing will hit. Don't be too sure. A truck can hit. So people who are careful, who want to promise or who want to assure and who want to stand on their integrity will say, I want to check what happens when one column fails. Then they will remove a column and then say, if it only collapses locally, it's okay. But if it collapses the whole building, then they will have to give strength somewhere else. So that is the kind of redundancy that we can do even today. It's a little difficult to convince people, so I'm not surprised, but I hope I have given you some more explanations.
Yes. So just one more doubt, sir.
Yes, yes.
Is there any guidelines provided by the government for high-rise apartment building structures for blast analysis or single column failure? Some analysis, some point is mentioned in any as a guidelines that they have to conduct this test or they have to do this analysis?
There are enough case studies on the web. You know, if you put in the web redundant structures, you'll get probably 500,000 cases. The trouble will be how to pick the one you want. So you need to consult somebody who is familiar with what to get. It is, in fact, it is too much data now. It's coming out of your ears. It's overburdening of your brain with information and data. So I would, if I were asked, I would rather check I know what to check. I know how to see. It's called data mining, in fact. I mine the data, web and send, okay, this is relevant to me, and I belong to many societies, so they report to me their failures. So I remember 5 years ago, Cross from UK did this, so I examine and find it. Otherwise, I conduct my own test. Most of the time, I conduct if it is my design, I conduct my test. If it is somebody else's design, I can get somebody else's example. But it's a good idea to check if something has been done. There are papers usually on failures. So it is going to take extra time. It means dedication, a commitment to what you give to the client. It cannot be paid for in rupees or dollars. It is something you have to decide yourself. Of course, I am not saying sacrifice your time, is suffering, make your family suffer, give them freebies. There are people who have enough money and they are only misers. They don't want to pay the designers. They will rather pay for interior decorators, stairs, curving stairs with no handrails. I say, don't bring in a pregnant woman or a baby or an old man. I won't come into it because if I shake, I'll fall down. So these are the things that are happening today. So the designer must be careful of potential dangers and conduct whatever computer testing. He doesn't have to build it exactly and do a prototype testing. But computer is your best lab, but you must know what you are doing. Finite element is a good tool, but you must know what you are doing. Otherwise, it's going to take you sideways elsewhere. It will give you wrong information. Sleipner, $700 million gone because of one computer input mistake. Anyway, these are exciting things to talk about. Thank you for asking.
Anyone have the questions or want to interact with us, sir?
I think Arpita can take home this experience of shaking my brain and making me say unplanned things. Thank you, ma'am.
Sir, I would like to thank you for.
I see VTU here. Excuse me. I see VTU here. Somebody from the university has no comment.
Actually,
anyway, thank you.
Yeah.
Yes, I'll give back to you.
Okay. I think VTU, anyone is there? Maybe not. Okay. Sir, you have given a wonderful insights, and I usually, when I speak with my students, I used to say them, if you are neglect. Okay, 1 minute. Namrata, she is having some questions. She has raised the hand. Madam,
Okay,
you can ask, madam. You can continue.
Yeah. Please go ahead and ask. I get so few.
Sir, hello, sir. I'm Namrata from Bangalore Nirmiti Kendra.
Okay.
Sir, I don't have any doubt. It was my second class that I'm attending your session. We are honored to hear such a great lecture, like a seminar for us. Thank you so much, sir. Thank you so much. It was a continuous 2-hour stretch. You took a class.
Class, no, it's a
It's
seminar.
not a class. It seems to be like thank you, sir. It was an awesome experience for us. It was my second class. Thank you, sir.
Okay, ma. God bless you. Okay.
And I would like to thank Arpita madam also. She has asked or interacted with you, sir. And I would like to thank on behalf of BMVNTFSA. And even I would like to thank on behalf of Venkatesh Babu, sir. He has also joined, sir, for almost 30 minutes he was there.
Oh, I see.
After that, he left. I think 5:30 to 5:45 he was there. Approximately in that time he was there. And I would like to thank even Srikanta Biji and even Janardhan, who is coordinating this program from
Thank you, Janardhan.
From our team. And I would like to thank even our director for giving us the opportunity for conduct such a wonderful program. Sir, I'm really, in my side, I am telling you thank you, because I have learned a lot of things in the last session also, this session also. Because I am basically from a geologist, I only think about the soil rocks, but after that structural elements, how it impact, no, that I have not. Now I can, even I can, when I'm giving the lecture, I can link these things for my students. I can give the more exposure to them along with this. Thank you very much for your wonderful session, sir. Thank you on behalf of all organizers.
You can see how much I enjoy talking. So thank you for the opportunity. Goodbye. Good luck. Be safe.
Okay, sir. Thank you.
Right.
Thank you, sir.